All right, today we're going to pull back the curtain on a really cool piece of tech that's quietly making our electrical systems way more efficient and, saving a ton of money and preventing some major headaches in the process. So let's just dive right in.
Let me start by asking you a question. What if I told you that you might be paying for electricity that does, well, absolutely nothing? It's this hidden cost, right? It could be lurking on your utility bill at this very moment, and today we're going to drag it out into the light.
So to really get what's going on, we need to introduce the villain of our story. There's this silent energy thief that's hanging out in your power lines. And this thief has a name, reactive power. The best way to think of it is as a freeloader. Seriously, it takes up valuable space on your electrical network, it makes your wires run hot, but it does zero productive work. It's just there, clogging up the system and causing problems.
Now this is probably my favorite way to explain it, the good old beer foam analogy. So picture this, your electricity is a big glass of beer. The actual beer, the liquid gold, that's your active power. That's the good stuff. That's what actually does the work, spinning a motor or lighting up a room. But that foam on top, that's your reactive power. It takes up space in the glass, but you can't drink it. It's useless. And the crazy part is, the utility company charges you for the whole glass, the beer and the foam. That's what we call apparent power.
And believe me, all that foam isn't free. It comes with some pretty hefty costs. For starters, utility companies will literally slap you with penalty charges for having too much of it. It also creates these extra currents that do nothing but heat up your system, which means you have less room to add new equipment. And all that extra heat puts a ton of stress on everything, which can drastically shorten the lifespan of your expensive gear.
Okay, so we've met the villain, but like any good story, there's a hero ready to step in. So let's meet the solution to our reactive power problem.
And that hero is the capacitor bank. So what is this thing? Well, put simply, it's like a little local generator, but just for that useless foam, that reactive power. Instead of you having to pull all that foam from the main power grid, the capacitor bank provides it right there on site, exactly where it's needed. This frees up your whole system so it can focus on delivering only the good stuff, that useful active power.
And it's not as complex as it might sound. It's really just made of three core parts. First, you've got the capacitors themselves. These are what store and release that reactive energy. Then you have switches and controls that are smart enough to connect or disconnect the capacitors depending on what your system needs at any given moment. And of course, you have a whole protective system, fuses and relays, to make sure the whole thing runs safely.
So we know what it is, but how does this thing actually fix the problem? Well, it all comes down to improving one single, super important number.
And that number is called the power factor. Honestly, the easiest way to think about it is as a health score for your electrical system. It's basically a report card on how efficiently you're using the power you're paying for.
And here's the key. The perfect score, the A+ on the report card, is 1.0, a nice round 1. That's what we call unity. It means 100% of the electricity you're drawing is doing productive work. No foam, all beer. That is the goal.
And this chart here does a great job of breaking down what these scores really mean. If you're up around 0.95 to 1.0, you're in great shape. But as soon as you start dipping below 0.85, you're getting into poor territory. That means you've got serious energy losses, you're probably getting hit with penalties, and you're running the risk of overheating your equipment. So a capacitor bank's whole job is to push your score as close to that perfect 1.0 as possible.
And when you improve that score, the benefits are immediate and they are huge. We're talking big savings on your bills and a much longer life for your very expensive equipment.
Let's just quickly run through the 4 biggest wins you get from installing a capacitor bank. You're going to reduce your electricity costs, extend the life of your equipment, get that power factor score way up, and slash your overall energy losses. It's a win, 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 win. The first one, and let's be honest, the one most people care about, is the direct financial savings. By generating that reactive power right where you need it, the capacitor bank stops you from having to pull it from the grid. And that means the utility company stops hitting you with those annoying penalty fees. It's a direct reduction to your monthly bill.
Second, it protects your investments. That reactive power creates extra current, and that current generates heat. And heat is a silent killer for things like motors, transformers, and cables. By cutting down that extra current, a capacitor bank lowers the thermal stress, which prevents damage and helps your equipment last so much longer.
Okay, this all sounds pretty great, right? But how do you actually know if you need one? Let's talk about the practical side of things.
Well, the simple answer is this.
You probably need a capacitor bank if your facility uses a lot of what we call inductive loads. Think about things with big electric motors, transformers, welding machines, even large-scale fluorescent lighting. These are the main culprits that gobble up reactive power and drag your power factor score down into the mud.
But, and this is a really big but, it's not a one-size-fits-all deal. Sizing is absolutely critical. If your bank is too small, you won't actually fix the problem and you'll still be paying penalties. But if you get one that's too big, you can create a whole new mess of problems like overvoltage, which can damage your gear and even lead to new penalty charges. It's got to be just right.
And you also have different options for how to install them, depending on what your facility needs. You could go with one big, centralized bank right at your main switchboard, or you could install smaller banks for specific groups of machines. You could even put a tiny, dedicated capacitor on a single, massive motor. Each strategy has its own pros and cons.
And this quote right here just sums up the whole impact perfectly. It says a well-designed capacitor bank doesn't just help you, it effectively releases capacity throughout the entire upstream network. Think about that. It makes the whole grid more efficient for everyone. It's a pretty elegant solution.
So I guess that just leaves us with one final question to think about. Now that you know about these hidden costs and the powerful benefits of fixing them, is your electrical system really as efficient as it could be?